Hello everyone. In this video we're going to learn all about the atom and how to calculate the amounts of protons, neutrons, and electrons in atoms. So to talk about what an atom is, we first have to talk about what they are made of. Atoms are made up of three subatomic particles: protons, neutrons, and electrons. So let's talk about protons first. The protons in this picture of an atom are red in color, and they have that little plus in the middle because protons have a positive charge. Each proton has a +1 associated with it. So this atom over here pictured has 3 +1 charges in its nucleus. Protons are always going to be found in the nucleus, and they have a specific weight associated with them. They weigh roughly, and that's what that little symbol means, 1.007276 AMU. AMU stands for atomic mass unit. Most of the time, we just say that they weigh about 1 AMU overall. Sometimes I will abbreviate protons because I don't feel like writing it out all the way, and that abbreviation is going to be P+. All right, and so again, that's going to be all of these red things in the middle here. Okay, our next subatomic particle that I want to talk about is our neutrons. All right, and those are going to be the blue things in that nucleus over there. They have no charge. They are also always going to be found in the nucleus. They weigh very slightly more than protons do. They're going to weigh roughly 1.008665 AMU. And again, AMU stands for atomic mass units, but we usually just say that they also weigh about 1 AMU. All right, if I want to abbreviate neutron, I'm going to use one of two abbreviations. We could do N0, or I could abbreviate neutrons like that. All right, our last subatomic particle that I want to talk about is the electron. Oops. So sorry. Electrons. And electrons have a negative charge. They are also really little, and they orbit the nucleus. They have a little bit of weight or mass associated with them, but again, it's a tiny amount, roughly 0.00055 AMU. Usually we just say they don't weigh anything because electrons are so small and they weigh so little that they don't really influence the overall mass of an atom at all. If I wanted to abbreviate electron, I would abbreviate that E-. And so in this picture, we can see that there's 1, 2, 3 electrons overall. Now, to talk a little bit about the periodic table, the element pictured in that photo that we've been labeling so far is lithium. All right? Lithium is on the periodic table, but that periodic table square represents a real atom. So you have to understand how to read the periodic table. So let's give you a little bit of information. For the atom lithium, and for every other element on the periodic table, you're going to find a number in the top of that box. For some periodic tables, it's in the upper left. For some, it's right here above the element symbol. But either way, that number on the top is going to be the atomic number. The atomic number is going to tell you two pieces of information. The first is the number of protons. Always. Lithium always has 3 protons. Beryllium always has 4 protons, so on and so forth. But the atomic number also tells you the number of electrons if and only if that atom is neutral. And meaning, by that I mean the atom is not in ionic state, which is something I'll talk about later. Basically, when our protons and our electrons match each other. All right. Next down, we've got the Li here. That's going to be our element symbol. And that's essentially just our abbreviation. Element symbols are always either 1 or 2 letters. Some elements only have 1 capital letter. Some elements are made up of 2 letters, 1 capital and 1 lowercase. Next down, we have our element name. And then finally, on the bottom here, we have our average atomic mass, that decimal number on the bottom of every single periodic table square. So that number is going to represent, again, average atomic mass. And what average atomic mass is essentially a weighted average of every single isotope of that element. And isotopes are just different forms of particular elements. However, if I round off 6.94, if I were to round the average atomic mass off to the nearest whole number, it would turn into a mass number. All right? And so let's just make a little bit of a note to ourselves over on the left-hand side over there. If I round that off to the nearest whole number and it turns into a mass number, mass numbers is equal to our number of protons plus our number of neutrons. All right, so let's say, for example, I wanted to figure out how many neutrons were in the atom lithium. What I would do in that instance is I would take this mass number here. I have to round that off. It's going to round off to 7. I'm going to take that mass number, which is protons and neutrons together, and I'm going to subtract out the number of protons, which is given by the atomic number up here. If I do 7 minus 3, that gives me a total of 4 neutrons. Okay, so let's practice calculating amounts of protons, neutrons, and electrons for different elements over here. Okay, first we've got helium. Helium is element number 2 on the periodic table. That number in the top of helium's box is 2, meaning that helium has 2 protons and helium has 2 electrons in neutral state. The number on the bottom of helium's box is 4.00 roughly. So I'm going to take that 4, that mass number, and I'm going to subtract out the atomic number 2, and that's going to give me 2 neutrons overall. Let's take our next element, beryllium. Beryllium is atomic number 4 on the periodic table, which tells us that beryllium has 4 protons and it has 4 electrons in neutral state. The number on the bottom of beryllium's box is roughly 9.01. So to calculate neutrons, I'm going to take that bottom number, round it off to the nearest whole. I'm going to subtract out the top number, 4, and that's going to give me 5 neutrons overall. Next, we've got our element radon, right? Radon is atomic number 86 on the periodic table. That tells me that it has 86 protons, and you guessed it, it has 86 electrons in neutral state. The number on the bottom of radon's box is 222. So I'm going to take 222 and I'm going to subtract out my atomic number 86, and that is going to give me 136 neutrons. Next down, we have our element copper, number 29 on the periodic table. So that tells me that copper has 29 protons, and copper has 29 electrons in neutral state. The number on the bottom of copper's box is 64, roughly. So I'm going to make sure to, again, round that number off. The actual number is 63.55, but again, that's going to round off to 64. And I'm going to subtract out my 29 for my atomic number, and that is going to give me 35 neutrons overall. Last but not least, we have barium, element number 56 on the periodic table, which tells me that barium has 56 protons. It tells me that barium has 56 electrons in neutral state. Barium's number on the bottom, its mass number or average atomic mass, is 137.33. We're going to round that off to 137. And we're going to subtract out the atomic number 56, and that is going to give us a total of 81 neutrons. I hope this was helpful in figuring out what makes up an atom and how to read each box on the periodic table. Please come talk to me if you have any questions.